Welcome to the Silverstone Technology Cluster's Ask the Expert podcast. I'm Jeannie, your host. The mission of the STC is to support advanced engineering, electronics and software businesses, and we're always keen to share industry knowledge and insights. In each podcast episode, we sit down with seasoned professionals and industry leaders to uncover valuable knowledge, share real-world experiences, and explore smart strategies for navigating the challenges of modern business in advanced engineering. Hi, and today I'm joined by Chris Moller from the Open University. Thank you so much for coming.
You're very welcome.
And so I know today we're here to talk about your combined AC and DC power supply that you're developing. But before we get on to that, can you just tell us a little bit about yourself and how you came to be working on this?
Well, I'm an engineer, been an electrical and electronic engineer all my life and freelance for a long time and retired 12 years ago now. And it's given me an opportunity to do things I'm really interested in doing and things that can make a real difference. And this is one of them.
Okay, so as I said, you've developed a sort of AC-DC combined power supply. Why do we need it? What problem is this solving?
Okay, well, the way we're using electricity in houses is changing. We've got new things that we want to do that we haven't been able to do before, particularly charging electric vehicles, but also solar panels and batteries. Lots of houses have got those now. And heat pumps are coming along, we're told, to heat our houses, and they work particularly well with DC. Okay,
so if they work particularly well with DC, why do we need AC as well?
We need AC because all the other things we have in our house, and which we've had for years, we've been committed to AC for all the appliances in our houses, since before the war. So that's not going to change in a hurry. So what I've been doing is looking at a way of providing both the AC that we need for everything that we have in our houses and the DC that we need for these new applications.
Okay, so these new applications, although they're new, they have been around for a while. So has anyone else tried to develop this?
Originally, the first houses that were electrified were in fact with DC a long time ago. So DC is not completely new. But it turned out that it was much easier to change voltage with AC. And so for various reasons, AC became the standard and the norm for everybody. But recently, DC has enjoyed a resurgence because the constraints on changing the voltage, which used to be there with DC, are no longer there. Now that we have high power semiconductors, we can change the voltage for DC just as easily as AC, actually.
Okay, so this combining AC and DC into a single supply, what does it do? How?
Well, the problem is that DC and AC are different, so various people have looked at the ways of providing both DC and AC to houses, and the solutions which are around. The people in Finland, for example, they provide DC to every house and then convert it to AC for all the historical things you have. The Dutch have a scheme whereby they're going to put a separate distribution network for DC, but that entails lots and lots of cable and lots of digging up roads and disruption and so on. In this country, we have what's called three-phase AC, which is used for farms and factories. And our plan is to use three-phase AC for houses too. Unfortunately, very, very few of our houses have three-phase, unlike much of Europe. So the problem that I came up with a solution for was how to deliver both DC and AC using the cable that is already in the street or up on the poles.
Okay.
And that's been the critical thing which has driven this particular invention.
So you don't need to lay any new cables, no new infrastructure. It works with what's already there.
Exactly that.
Okay. And you mentioned, you sent me a video before this, so I've read a little bit about it, watched a little bit about it, and I think what you were talking about in that video as well is the ability for it to work bi-directionally.
Well, bi-directionality is really important because we're not just consumers of electricity anymore. We also generate electricity with our solar panels, and we have batteries, and we can also provide a useful function to the grid whereby we can sell electricity back to the grid at times of particularly high demand. So being able to transmit electricity in both directions is a really useful asset. Obviously, it's important to be able to do that with DC. Increasingly, the industry is focused on making bidirectionality possible for AC, but it turns out that that's really complicated.
Okay. So why has no one done this before?
Why has no one done this before? Well, I think the electricity industry is a very conservative industry. It has honed the way it delivers AC over many, many years, and it's not very good at thinking completely outside the box. And I think that's something that we can offer.
Okay, and other solutions have been tried with this. Obviously, what are the other solutions, and why do you think that this solution works better than?
Well, the Chinese have worked on combined AC and DC down a single cable, but their solution is really complicated, and it's also not bidirectional. And also, you have to have both DC and AC together in their solution. In ours, you can have AC or you can have DC, or if you have a need for both, you can have both, and that's really attractive.
Okay, so how we need electricity. It's not like you can turn all the power off and you can implement this. Because it's so crucial, how would you transition to a new system?
Well, transition is really important. We can't go along and tell people, "I'm sorry, you're going to be without electricity for a week while we do it." That's just not possible anymore. When we transitioned from town gas to natural gas, it took us 7 years, and that was just with probably 2 or 3 appliances in each house. So transition is a really, really big issue. What I've looked at in this system is a transition process whereby you have a 2-hour outage at a point where you install special equipment in the meter box outside the house. And you do that for each house in turn. When all the houses on the substation have had this box put on the house and nobody has seen any difference to what's happening, then you go and change the substation and make the substation combined AC and DC. And hey presto, all the boxes you've installed on all the houses come to life, and you get AC and DC. So 2 times 2-hour outages is something we can live with.
Yes, of course. And I know you've built a model, obviously a small scale model. What do you need to take this idea further? Because obviously you've got the idea and you know it works. How do you get to the next step?
Well, we've proved the science on the lab bench, but there's a lot of engineering that needs to go into scaling that up. In fact, the scaling up has to be a factor of 20 on the voltage and 20 on the current, which is quite a lot. And it may well be that in the process of doing that, we come across other engineering challenges that have to be solved. And we won't really know that until we try and scale it up.
Okay. So I think a big question, especially in the climate now, that what we're hearing about with different, especially businesses driving up costs, does it do anything for energy efficiency? Are there going to be savings there?
Well, one of the big surprises of doing the sums on this is that obviously you lose energy in the cables that go along the street. And it turns out that when you put DC and AC down the same cable, the amount of heat dissipated by the cable down the street actually goes down, which is amazing. And so certainly as regards the heat loss in the cables, it will be lower with this system than it would be with either AC or DC on its own, which is a fantastic result, actually.
Okay, so another question about the cables. In the short video that you sent me, which I will, with your permission, share in the show notes so anyone can watch it, you talked about people have come up with other solutions, but they require a lot of copper. And this requires less copper?
This requires no extra copper in the street. In contrast with the Dutch system, which requires doubling the amount of copper in the street. The UK system, if we're going to put 3-phase into every house, requires every cable into every house being changed from single-phase to 3-phase, which is a lot more copper. So, yeah, absolutely. The other solutions all require much more copper than this solution.
Okay, so you talked about installing a box on every house. I think the big question is who pays for that?
Well, one of the main benefits of being able to separate the AC and the DC is that clearly if you're going to impose it on every house on a substation, then the utility is going to have to pay for the box that provides AC, so that everybody can just carry on as they were before. And so part of the exercise has been to minimise the cost of that box, which keeps the AC the way it is today. However, if you want DC as well, then you need a separate box, and clearly the user would pay for that. So you pay for the ability to fast charge your
Okay.
car and connect your solar panels and batteries and so on.
Okay, so it's really, if you want the convenience of it,
Yes.
you pay the uplift on it.
Yep.
Okay, that sounds fair.
I hope so.
So what's next? Where are you going now?
We've got a company not a million miles from here who is ready and poised to scale this up. They just need some money to do it.
Brilliant news.
Yes, we know exactly how we're going to do it. They know which devices they're going to use. They've scoped it out fairly thoroughly. And so all it needs is money to make it happen. That will take us to a 3 kilowatt prototype. And then probably we will need another slug of money to take it from 3 kilowatts to 20 plus 20 kilowatts or thereabouts.
Okay, well, best of luck with it. And I look forward to watching it progress and seeing where you are 5 years from now.
Thank you very much.
And thank you for joining me today. It's been really informative, and I think something that actually is really important for the future and for how we live.
Yeah, well, we think so too. So thank you.
It's been fantastic to have you. Thank you.
Thank you.
That's it for this episode of Ask the Expert. Thank you so much for listening or watching. We hope you picked up some useful insights and inspiration along the way. If you enjoyed the conversation, please give us a like, share or rating on the platform you're using. Please follow Silverstone Technology Cluster on LinkedIn and subscribe to the STC YouTube channel or our podcast on Spotify or Apple, so you never miss an episode. We'd love to hear from you, so if you have any comments, a particular topic or a guest you'd love to hear from, please drop me an email to Jeannie at silverstonetechnologycluster.com. Bye for now.